Hello students, this is the first problem under module 2 based on the NR method as well as fast decoupled method. For the network shown in figure 1, with bus 1 as a slack bus, use following methods to obtain one iteration. For load flow solution, the line and bus data is given in table. Okay, these two tables. Okay, we have to use NR method as well as fast decoupled method. This is a given network. We have 3 buses, 1, 2, 3 and 3 lines we have. This is a line data given. Line 1, okay, so which is connected between bus 1 and 2, which has a line impedance of 0.1J, okay, and line number 2 which is connected between 2 and 3, which has a value of 0.J2 impedance, and line 3 which is connected between 1 and 3, which has an impedance of J0.3, and half line charging admittances are 0. Okay, and the table 2 gives the value of bus data. Okay, here bus number 1 which is a slack bus, and bus 2 which is a PV bus, bus 3 which is a PQ bus. Okay, and generator load data, generator data, load data and voltage magnitude and Q limit is given. Okay, we will solve the problem. First we have to form the Y bus. Y bus can be formed by rule of inspection method. So inverse of Z12 which is minus 10, and inverse of Z23 which is minus 5, and inverse of 0.3 J0.3 it is minus 3.33. So let it be 0.5 J0.5. Inverse of Z13 which is Y13, small y13 which is minus 5. Okay, minus 5 G. Okay, so Y bus will be using a rule of inspection method, which is minus J15, J10, J5, J10, minus J15, J5, J5, J5 and minus J10. Okay, so we want it in a polar form, not in a rectangular form. So we can write this same Y bus like this: 15 at an angle minus 90, 10 at an angle 90, 5 at an angle 90, 10 at an angle 90, 15 at an angle minus 90, 5 at an angle 90, 5 at an angle 90, 5 at an angle 90, 10 at an angle minus 90. Now we have to find the value of P2. Okay, because first bus is a slack bus, no need to consider. Second bus which is a PV bus. So we have to find out the value of P2, right? P2 can be calculated by using this formula. Pi is equal to summation Vi Vk Yik cos theta Ik plus delta K minus delta I. So calculating we get summation V2 Vk Y2k cos theta 2k plus delta K minus delta 2. Okay, so here K varies from 1 to 3, so it would be V2 V1 Y21 plus cos theta 21 plus delta 1 minus delta 2 plus V2 square Y22 cos theta 22 plus delta 2 minus delta 2 cancels each other, it remains with cos theta 2 only, plus V2 V3 Y23 cos theta 23 plus delta 3 minus delta 2. Okay, here delta 3 delta 2 are not given. You assuming flat start, we get delta 1 delta 2 delta 3 is equal to 0 degree, as well as V3 is not given. Assuming flat start, V3 can be taken which is equal to 1. Substituting everything, cos 90 everywhere we get cos 90 value which is 0, so whole value is 0. Similarly, P3 is calculated using this formula. Okay, summation V3 Vk Y3k cos theta 3k plus delta k minus delta 3. Okay, here also cos term, cos 90 which is equal to 0. So answer we get which is equal to 0. Okay, and delta P2 which can be calculated using this formula, P2 scheduled minus P2 calculated. What is P2 scheduled, which is Pg2 minus Pd2. What is P2 calculated? Just now we have calculated P value. Okay, we'll see what is Pg2. Pg2 which is not given, which is given 5.3217. Pd2 which is not given, the demand, okay, the real power generation at the load side which is not given. So 5.3217 minus 0 minus P2 calculated, it is 0. So delta P2 is equal to 5.3217. Similarly, delta P3 can be calculated like this. Delta P3 is equal to P3 scheduled minus P3 calculated. Okay, so P3 scheduled which is P3 generation minus P3 at the demand side. Okay, real power at the generation side which is not given, so take it as 0. Okay, real power at the demand which is 3.6392. Okay, minus P3 calculated which is equal to 0. Substituting we get minus 3.6392. Okay, so delta P3 is equal to minus 3.6392. Similarly, Q3 is calculated using this formula. Qi is equal to summation Vi Vk Yak sin theta Ik plus delta k minus delta I. Calculating, we get V3 V1 Y31 sin theta 31 plus delta 1 minus delta 3 minus V3 V2 Y32 sin theta 32 plus delta 2 minus delta 3 minus V3 square Y33 sin theta 33 plus delta 3 minus delta 3 cancels each other. V3 value is 1, V1 value is 1, Y31 value just now we have calculated. Y31 it is 5, Y32 5 and Y33 which is 10. Okay, and theta 31 which is 90, theta 32 which is 90 and theta 33 which is minus 90. Substituting everything we get here V2 is 1.1, here V2 is 1.1. Substitute that. Okay, we get minus 1 into minus into 5 sin 90 minus 1.1 into 5 sin 90 minus 1.1 square into 10 sin minus 90. Answer we get minus 0.5. Minus 0.5. Okay, similarly, similar to P2 P3, delta Q3 can be calculated. Delta Q3 is equal to Q3 scheduled minus Q3 calculated. Okay, Q3 scheduled which is equal to QG3 minus QD3 minus Q3 calculated. Okay, QG3 which is not given, I mean reactive power at the generation side is not given, but reactive power at the load side which is given 0.5339 minus 0.5339 minus of minus 0.5. Okay, so it becomes plus 0.5. The answer is minus 0.0339. Right. So delta 3 is calculated, delta P3, delta Q3, delta P3 and delta P2. Similarly, MII, MIK, J3 matrix elements and J4 matrix element, LII, LIK. Okay, let us calculate all these things. We know that second bus is a PV bus, third bus is a PQ bus. So we need to find out the value of P3 and partial differentiation of it. Okay, we have to calculate P3 and P2 and partial differentiation of this, and Q3 and partial differentiation of this, right? So therefore matrix H, okay, matrix H, which will be having elements H22, okay, and H33, these are the diagonal element. What is H22? H22 is dou P2, partial differentiation of P2 with respect to delta 2, and partial differentiation of P3 with respect to delta 3. Similarly, we have to find out H23 and H32. What is H23? It is partial differentiation of P2 with respect to delta 3, and H32 partial differentiation of P3 with respect to delta 2. Similarly, the matrix submatrix N, here we have to find out N23 and N32, that is partial differentiation of P2 with respect to V3 and partial differentiation of P3 with respect to V3. Okay, similarly we have to find out submatrix M, which is a partial differentiation of Q3 with respect to delta 2, partial differentiation of Q3 with respect to delta 3. Similarly, L, we have to find out partial differentiation of Q3 with respect to V3. Okay. Therefore, matrix delta P2, delta P3, delta Q3, which is equal to H22, H23, H32, H33, N23, N33, M32, M33 and L33. Okay. From this we get delta delta 2 and delta delta 3 and delta V3. Okay. So before finding delta delta 2, delta delta 3, delta V3, we have to find H N M L matrix. Let us find out. The diagonal element HII, which is equal to summation VI VK YIK sin theta IK plus delta K minus delta I, but K is not equal to I. So here I is, okay, calculating H22, I is 2, okay, K varies from 1 to 3, okay, but K is not equal to I. So we get V2, V1, Y21 sin theta 21 plus delta 1 minus delta 2 plus V2, V3, Y23 sin theta 23 plus delta 3 minus delta 1. Okay, substituting everything and calculating, we get here V2 is equal to 1.1 and V1 is equal to 1, Y21 10, sin theta 1 90, okay, delta 1 and delta 2, okay, taken as 0, 0 plus 0 plus 1.1, 1 into 5 sin 90 plus 0, okay, so finally we get 16.5 per unit. Okay, similarly H33 can be calculated. V3 is 1, V1 is 1, Y31 5, sin 90 plus 0, 0 minus 0 it is 0, plus 1 into 1.1 into 5 sin 90 plus 0. Okay, so sin 90 it becomes, solving we get sin 90 is 1, okay, into 5, okay, 5 plus 5.5 we get 10.5. Okay, similarly we will calculate H23 and H32, both are equal, so we get here V2 is my 1.1, V3 is 5, okay, sorry, V3 is 1 and V2 3, which is 5, and sin 90 to sin theta 2 3, which is 90, and delta 2 0, delta 3 0, so minus of that, so we get minus 5.5. Similarly H32. Okay, so let us calculate the value of matrix N. Here N23 can be calculated using this equation, Vi Yik cos theta Ik plus delta k minus delta I. We know that delta k it is 0 and delta I it is 0 here, and theta which is 90, okay, cos 90 value which is 0, so whole term which will be 0. Similarly here cos theta I is there, cos theta Ik plus 0 is there, okay, so cos 90 and cos 90 is 0, therefore N23 is equal to 0 as well as N33. So N23 is equal to 0 and N33. Similarly, we will see what is the value of M33. Okay, M33 also same thing here, MII which is equal to MII which is equal to Vi Vk Yik cos theta Ik plus delta k minus delta I. Delta k and delta I are 0, cos theta Ik the value which is 90, cos 90 is equal to 0, so M33 is 0. Let us see what is M32. M32 here also same thing, minus Vi Vk Yik cos theta Ik plus delta k minus delta I. Delta k and delta I is 0, so theta Ik is 90, cos 90 which is equal to 0, therefore M32 is equal to 0 and M33 is equal to 0. Now we have to find out the value of L33, correct, L33, okay, which is partial differentiation of Q3 with respect to V3. Okay, we will use this formula. Using this formula we get here 2V3, okay, V3 is 1 and Y33 10, sin theta 33 minus 90 minus V1 which is 1 into 5 into sin theta 31 sin 90 plus delta here it is 0, okay, minus V2 1.1 Y32 5 sin 90 plus delta 2 minus delta 3, okay, these are zeros, okay, therefore simplifying first term we get 20 minus 5 minus 5.5, so we get 9.5. Therefore the matrix would be HNML matrix would be 16.5 minus 5.5 minus 5.5 10.5. This is H matrix, okay, N matrix which is 0, okay, this is second row, second column, third column, third column, second row, third row, third row, okay, here it is 0, here it is 0, and this is 9.5 into delta theta 2 delta 2 delta 3 delta V3, okay, in per unit we represent it by delta V3 divided by V3, okay, which is equal to delta P2 delta P3 delta Q2, okay. So already we have calculated delta P2 which is 5.3217, right. delta P2 which is (5.3217) and delta P3 which is minus 3.6392 minus 3.6392 and delta Q3 which is minus 0.0339. Okay, so we have to find out the value of delta 2, delta 3, delta 3 and delta V3 divided by V3. So this here inverse of Jacobian into delta P2, delta P3, delta Q2, okay, gives the value of delta 2, delta 3, delta V3. So using Calc, first make sure that your Calc mode in matrix. Okay, so pressing 6 you get matrix mode, then okay, press shift 4. Okay, it is asking whether you want to enter the data, okay, dimension. Yes, I want to enter the dimension. Okay, press 1. Okay, take matrix A. Okay, matrix A, let it be inverse of Jacobian, okay, which has an order of 3 cross 3. So press 1. Okay, so I want to enter all the values. 16.5 minus 5.5, 0, minus 5.5, 10.5, 0, 0, 0, 9.5. After this, okay, press shift 4. Okay, once again go to dimension. I want to enter second matrix. Second matrix is this matrix delta P2, delta P3, delta Q2. So order of the matrix is 3 cross 1. So press 3. Okay, press 3. Okay, so values are 5.3217 minus 3.6392 minus 0.0339. Correct. So after pressing this, what you have to do is shift 4 once again. Okay, so matrix A inverse has to be multiplied with matrix B, right? So 3 inverse into shift 4. Okay, matrix B is a fourth option. 4, press equals, we get 0.2507. Okay, and second value minus 0.215 and third value which is minus 3.56 into 10 raised to minus 3. Okay, so we can write that as minus 0.00357, right? We'll calculate a delta to k plus 1, taking first iteration k is equal to 0. Okay, so delta to 1, delta to 1 which is equal to delta 1 0 initial value sorry, delta 2 0 which is 0 plus delta 2. Just now we have calculated delta 2, the value which is 0.2507. Okay, so it would be 0.2507 or 0.25 simply. Okay, so similarly delta 3k plus 1k is equal to 0, so we get delta 3, okay, delta 3 1 which is equal to delta 0 which is delta 3 0 which is sorry delta delta 3 k plus 1 or delta 3 1, which is equal to delta 3 0 plus delta 3 0. Okay, so delta 3 0, which is 0, and delta 3 just now we have calculated, which is minus 0.215, minus 0.215. Okay, so minus 0.215. Similarly, delta V3, okay, divided by delta V3, I mean it is in per unit. Already the value obtained is in per unit, so which is V3 0, okay, plus delta V3 0, okay, so V3, okay, the per unit value of this is 1 plus delta V3, okay, just now we have calculated, it is minus 0.00357, okay. Simplifying, we get 0.996, okay, 0.996 per unit. At the end of first iteration, we are going to obtain delta 2, which is equal to 0.25, and delta 3, which is minus 0.215, and delta V3, which is in per unit, 0.996. Using fast decoupled method, delta Pi divided by Vi is equal to Vi dash delta I, delta Qi divided by Vi is equal to Bi double dash delta Vi. Okay, so we have to find out delta Pi divided by Vi. So we have to find here PV bus as well as PQ bus we have, right? So we have to find delta P2 divided by V2, delta P3 divided by V3. Delta P2 already calculated, it is 5.3217 divided by 1.1, and this is minus 3.6392, okay, divided by 1, which is equal to, okay, dividing, we get 4.83, okay, or 8379 or 838, okay, this is minus 3.6392, which is equal to Bi dash means what? Minus Bi, correct? Okay, so this is the square matrix, so we have to find out beta 22, beta 23, beta 32, beta 33, already calculated. So we get beta, B is inverse of, it is inverse of x, right? Inverse of x. So this is a y bus, this is B, correct? So it is an imaginary value or B. So B22, which is minus J15, B23, which is 5, 32, B32, which is 5, and B33 minus 10. Okay, taking minus of this, it would be plus 15 minus 5 and plus 10. Okay, so it would be plus 15 minus 5 10, okay, into delta 2 delta 3. Okay, so taking this B matrix other side, we get delta 2 delta 3, which is equal to, this is B inverse, okay, minus B inverse into 4.83 minus 3.63. Okay, so take Cal C, press mode and press 6. Okay, it is in matrix form now. Okay, so now press shift 4. Okay, it is asking whether you want to enter dimension or not. Okay, first take first option, dimension. Okay, take first matrix A. Matrix A, let it be matrix B. Okay, B inverse, okay, which is a square matrix, right? Square matrix, and order of the matrix is 2 cross 2. So press 5. Okay, so A, which is 15, matrix A, which is first value is 15, minus 5, press equals, minus 5, press equals 10. Okay, so shift 4 again, shift 4 again, dimension. Okay, we have to enter another matrix. Okay, let it be matrix B. Okay, shift 2, press 2. Okay, the order of the matrix is 2 cross 1. So press 6. 4.83 minus 3.63. Okay, so now what we have to do, shift 4. Okay, matrix A, that is 3, option 3, inverse into shift 4 matrix B. Okay, so we get answer 0.2412. Okay, delta 2, which is 0.2412 minus 0.2424. Okay, these are delta 2 as well as delta 3. Okay, so we have to find out the value of V3. How do we find out? Using this formula, delta Q3 divided by V3, okay, which is equal to B double dash, that is B33, okay, minus B33, B double dash means what? Minus Bi, so it is minus B33 into delta V3. Okay, delta V3. Delta V3 can be calculated by rearranging delta Q3 value, which is minus 0.0339. Okay, divided by 0.339 divided by 1 V3. Okay, into minus B33 inverse. Okay, minus B33 inverse, minus B33, which is 10. Okay, minus 10, minus of that it is plus 10. Okay, inverse of this it is 0.1. Okay, into 0.1. So we get minus 0.0339 only. Okay, now we have to find delta 31. Okay, which is equal to delta 30 plus delta 3. Okay, delta 30 it is 0. Okay, delta 3 it is minus 0.2424. Similarly, delta 2 dash, which is delta 0 plus delta 2, which is equal to 0.2412. Okay, similarly V3 1, which is equal to V3 0 plus delta V3 0 it is 1 plus 0.0339, which is 1 minus 0.0339, which is equal to 0.966. Okay, so this is the obtained V3 dash and delta 3 dash delta 2 dash considering fast decoupled method. Thank you.